In this video, we're going to look at some quick examples of graph transformations. What I'm going to do is draw a quick sketch of a graph. So we might have some function of x. So if we go ahead and draw this, we might be given some points. So let's put this point right here, and then we'll have this one like so. So what we'll say then is that this is the f of x. So if we put on that this is going to be now 2, 0, let's say that this point is going to be 5, 4, and we'll say that this point right here is going to be 0, 3. So this is our function of x. We have different transformations. If we first look at translations, we know that the translations simply move the graph. We have two sorts. We have the f of x plus a, which gives us now a vertical translation, and the vector we have is 0a. If we have the f of x plus a, we have now a horizontal translation, and it's minus a, 0. If it's on the outside, it affects the y coordinates. If it's on the inside, it affects the x coordinates. So these are translations. If we now look at reflections, we have two different types of reflections. We have minus f of x, and this now is reflection in the x-axis, so reflection in x, and then we have f of minus x, which is a reflection in the y-axis. Again, if it's on the outside, we're going to be affecting the y-coordinates. If it's on the inside, it's going to be affecting the x-coordinates. Finally, if we look at stretches, we have two different types of stretches. A f of x, and this is a scale factor of a in the y direction. Then we have f of ax, which is a scale factor stretch of 1 over a in the x direction. If you need a full tutorial on graph transformations, there is one on the link at the top of this video, just here. This is purely giving some quick examples. So if we look at this now, and we were asked to do minus f of x. So if we consider this is the f of x, if I wanted to do minus f of x, this would be a reflection in the x-axis. So we'd end up now with the following scenario. Instead of having this point going up in this direction, we would end up now with it coming down like so. Instead of going up this way, we would now reflect that, and that would look something like so. So with this one, all we need to do is go ahead and put the coordinates on here, and we would be expected to state them. So we have now 2, 0, that doesn't change. This one now is going to be 5, minus 4. We know if it's on the outside, it's affecting the y coordinates. So in this particular case, we're multiplying the y coordinates by minus 1. So this one right here is 0, minus 3. So that gives us now an example of minus f of x. If we now look at another one, let's go ahead and look at another one. We'll do this time, let's do, and we'll have 2f of x. So this is now 2f of x. It's a scale factor stretch of 2 in the y direction. So if we consider this point right now, this is going to go from 0, 3 to 0, 6, and this is going to go from 5, 4 to 5, 8. So let's now show that, and when you're doing these, some stretch, just to show you know what you're doing, will get you the marks. So 2, 0 stays the same, as if we multiply it now 2 by 0, we still get 0, and then we get now the 5, 8. These don't have to be immaculate, but it just gives some idea. So we've got 2, 0, we've got now 0, 6, and we've got 5, 8. So give some idea. You might want to make that slightly lower and this one slightly higher, but essentially we're just showing that we've multiplied the y coordinates by 2. So 0, 6, 2, 0, and then 5, 8. Okay, let's do another one, and let's do another example. Let's say we had now, and this time we're going to do the f, and we will do the f of x minus 2. So this time now we're going to move everything 2 to the left, 2 to the right, sorry. So this point right here is going to go now 4, 0. So we're going to have 4, 0. We're going to have this point just here, which is going to now add 2. So that's going to become 7, 4. So let's put that just there. And then in terms of this particular one, we wouldn't now be expected to put it on. We would just go ahead and show that this has been translated now, and it's going to be translated by 2 to the right. So let's do that, and it's exactly the same graph shape, it's just been moved. If you want to, you can write to the examiner, you can say now translated, so translated 2 units to the right, or in the positive x direction. So some basic transformations. Let's look at another one. Let's look at the following. Let's look at the f, and we'll do this one. We'll do the f of 2x. So this now is going to be a 1 over 2 scale factor stretch in the x direction. If we have f of 2x, we're going to halve the x coordinates. If we had f of 1/2 x, we would double them. So let's just go ahead and do that one here, so we can still see our original. So this point is going to go from 2, 0 to 1, 0. So we're going to have this point just here, that's going to be 1, 0. This will remain at 0, 3. If we divide 0 by 2, we get 0. This one is now going to come to this point right here, and it's going to be 5 over 2, 4. So all we're doing here is dividing now the x coordinates by 2. So let's go ahead and do that, and then we'd end up with something looking like so. So it's now being squeezed towards the y-axis. We've divided all of those coordinates by 2. If we consider now, let's just do one more. Let's say we had the f of x minus 1 and then minus 2. All we would do with this one now is simply translate it. We could use the vector now 1 minus 2. So we would move it 1 to the right and then 2 down. So that's all we'd need to do, and we could simply go ahead and plot these points. So if we think about where this one would go to, this one would go to 1, 1. So we wouldn't need to show that. We would need to show this one, and this is going to go to 3, and let's just write this here. This is going to go to 3 minus 2. So what we've done is now moved 1 to the right and 2 down. This would be moved 1 to the right, which would give us 6, and then down 2 we would end up with 2. And we'd simply go ahead and plot those points. We would have exactly the same shape, there's no alteration in shape, and it would look something like so. So those right there, it would do give or take, something like that. That's not immaculate, but all we've done is translated it by the vector here. So with this one, we use a translation vector now of 2, 0. So that gave us the 2, 0. And now if we had one purely with the f of x plus a, we would have now a translation in the y direction. So there are some examples of transforming graphs. Again, it's not all of the possible scenarios that you may meet, but it gives you some idea if you have the skills to do it.